Hey guys, this is Mr. Holly. We are looking at lesson 9 today, representing proportional relationships with equations. In this lesson, what we're going to try to do is take a verbal description and as well as a table that's accompanied by a verbal description. We're going to try to write equations for these proportional relationships and then use those equations to project for different quantities. If I were to ask, if you were given so much of this quantity, how much would you have of the other quantity? We're going to use the equation to answer that question. So, in our first example, we're talking about a boy named Jackson and his grandfather. They construct model birdhouses. Many of their neighbors want to buy them. Jackson decided that building birdhouses could help him earn money for summer camp. He's not sure how long it will take for him to finish the request for the birdhouses. If Jackson can build 7 birdhouses in 5 hours, write an equation that would allow Jackson to calculate the time it will take for him to build any number of birdhouses, assuming he works at a constant rate. All right, so I have a ratio, 7 birdhouses, 5 hours. Every time I do this problem every year, I kind of get this question of, well, what would be my rate? Do I want to know how many hours it takes to build a birdhouse, or how many birdhouses I can build in an hour? And honestly, I would say that you would be okay either way. However you do this problem, it would be okay. But what I'm going to do is I'm going to take my ratio of 7 birdhouses to 5 hours. I'm just going to write that ratio here, 7 to 5. And it's important that I do this. I'm going to say that this is my number of birdhouses, 7 birdhouses, and 5 hours. And if you'll remember, when we've tried to find our constant so far, we've always divided our y divided by x, and that's how I would get a constant. So in this case, if I want to treat this ratio as my constant, 7/5, 7 divided by 5 gives me a ratio of 7/5, or 1.4 if you want to do it as a decimal. This also is how I'm going to define my variables. So remember that y over x is how I find my constant. So that shows me that my y variable in this situation is going to be birdhouses, and my x variable in this situation is going to be hours. Typically, I like to choose time as my x variable, and there's a lot of reasons for that, but I will just say generally, time is independent. Time doesn't depend on anything else, and when we talk about independent dependent variables as we do this unit, the independent variable is always going to be your x value. Time doesn't really depend. The amount of birdhouses, in my opinion, depends on how much time I spend building birdhouses. Time never depends on how many birdhouses are built, right? So from that thought process, I'm going to say that the hours needs to be my x variable, and that's why I have it on the bottom. That's why I have it in my denominator. So here's my constant. It's going to tell me the amount of birdhouses built per hour. And if I want to write that equation, I would just say y is equal to 7/5 x, or y equals 1.4x. And in this, it's very important for us to know that y represents birdhouses, while x represents hours. Okay. Now, the B part of this question says, how many birdhouses can Jackson build in 40 hours? Well, let's take our equation. I'm going to use the decimal because I think it's going to be easier when we multiply. And it says y is equal to 1.4x. Y is our number of birdhouses. X is our number of hours. We're asked in 40 hours, how many birdhouses can we build? So I have an x value. The value for my x quantity, hours, is 40. So I'm just going to go ahead and multiply that, and I would find that y is equal to 56. 56 birdhouses. All right, so all we have here is this multiplicative relationship between x and y, and you're going to be given one value. You're either going to be given an X or a Y, and you need to find the other one. Let's look at C. How long will it take Jackson to build 35 birdhouses? All right, so let's look. Y equals 1.4x. In this scenario, I'm given the number of birdhouses. So let's take the number of birdhouses, make it 35. So that's equal to 1.4x. Now, how would I solve for x? I'm going to divide by the coefficient here. And 35 divided by 1.4 is 25. And that would be equal to x, my number of hours. So 25 hours. All right, let's check out D. How long would it take to build 71 birdhouses? Same process. Y equals 1.4x. Is birdhouses, is that my Y variable or my X variable? It's my Y variable. So birdhouses will go in place of Y. Now I need to figure out X, which represents my number of hours. Just divide by 1.4, divide by 1.4, and I would get X is equal to 71 divided by 1.4. 0.714 something. Let's convert that to a fraction. So on my calculator, I'm going to hit second, and I'm going to do fraction of decimal back and forth like that, and it's 50 and 5/7. So 50 and 5/7, and that is my number of hours. Now, if I wanted to be precise, I could try to do that in minutes, but the number of minutes is not divisible by 7. I don't really think I think that's probably our best answer right there, 50 and 5/7 hours. Okay, so again, I'm just going to take whatever quantity I'm given. I'm going to plug that in for the appropriate variable, whether it's my X or Y variable, and I'm going to find the other proportionate quantity. All right, on number 2, we have a similar scenario. We have 2 produce stands. We are given ratios for each. 6 ears of corn for $1.50, 13 ears of corn for $3.20. Now, anytime I'm working with money, I usually choose money as my Y variable. That makes sense to me because I want to know how much it costs per item. I don't want to know how many ears of corn I can get for $1. I want to know how much it costs per item. So in this case, I'm trying to figure out how much money it costs per ear of corn. So Y over X, I can find that constant by doing 150 divided by 6, and I would get, I'm going to just write it here as 25 cents. Okay, that is my constant. Now on this one, I have $3.12 divided by 13, and that is 24 cents per ear of corn. Okay, now here are my equations. Y equals 0.25x or 2500x, and Y equals 2400x. Now I can use these values in the table, and I can complete the table. So ears is my X variable, so if I plug in here 0.25 times 14, that should give me a Y value of $3.50. And if I use 21 as my X variable, 25 cents times 21 is $5.25. And now I'm going to come down here and I actually have $50 as my Y variable, and that's equal to 25 cents times, well, that's 1/4, so 1/4 of 200 would be 50. So I'd be able to get 200 ears of corn for $50. All right, now I'm going to have to do the same thing on this side. If my constant is 24 cents. My x value is 14. I'll do 24 cents times 14 ears and get $3.36. $3.36. Sorry, I didn't write 14 in here. That's my x value of 14. All right, now let's do, what if it's 24 cents per ear and I have 21 ears of corn? Well, multiply 24 cents times 21 ears, $5.04. And now on the last one here, we're provided with a y value of $49.92, and 24 cents is my constant. I do not know what x is. I'm going to have to actually probably solve this one. And the way I'm going to solve for x is I'm going to say, I'm going to divide by the coefficient. And in this case, x would be equal to $49.92 divided by 24 cents, which is 208 ears of corn. Checking out time. So, in the past, when you've been given tables like this, you've usually just tried to scale up, right? So in this case, you know, maybe it was 6, 12, 18, something like that. What you should be noticing here on this problem is this is kind of increasing randomly, right? Our x values are given randomly. So we really can't do this scale up. There's not a good multiplier to go from 6 to 14. I mean, that's 2 1/3. 6 to 21 is 3 1/2. I mean, in theory, we could do that, but it is not. There's not really a good multiplicative relationship there. From 13 to 21, there's not a good multiplicative relationship. Okay, so I'm not really looking to create equivalent ratios like we've done in the past, where we might do, if 6 ears of corn is $1.50, then 18 ears of corn is, and I would just multiply by 3 and get $4.50. Like, that's the proportional thinking we've used previously. In this lesson, hopefully we've been able to switch to, well, I can find the proportional relationship by writing an equation, and then if I put one quantity into the equation, that equation should produce the other quantity, either by multiplying the constant times x or y divided by the constant to give me my x quantity. All right, guys. Hopefully that helps out, and good luck at home. Let us know if you need us.